So hello everyone, I Raghvendra Singh. Welcome you all in this channel. So today we are going to discuss some very basic concept of engineering mechanics. Engineering mechanics. So first of all, I think we should start from introduction. So basically, mechanics is a minor or equal part of 12th physics. Sorry, not 12th physics, I should say 11th physics. Mainly when it comes in friction and rotational motion, and these all topics I think you have studied in your 12th 11th class or also in IITJ preparation. Yeah, so basically I will start from just basic only. So let's start with introduction. Okay, so basically mechanics. Mechanics. Basically mechanics have two parts. First, mechanics of solid, mechanics of solid, and second, mechanics of fluid. Okay, so these are major two types, and here we comes in solid. Majorly we studied in solid, all about solids in our syllabus. So mechanics of solid can be further divided in two parts, that is mechanics in rigid body, mechanics in rigid body, mechanics in rigid body, and second can be mechanics in deformable bodies. I also told you that what does it mean rigid and deformable. Deformable, deformable bodies, deformable body. Yeah, so basically let's talk about this rigid body. What does it mean rigid body? Basically, what is rigid body? So we can say that when we are applying force and the shape of body, also dimension and shape and dimensions are not changing, so we can say that is rigid body. Basically rigid body not possible, so we consider it is deformable. So we can say that a body which size size and also dimension and shape do not changes, do not changes. So that is called rigid body. So like this rigid body is not possible. So we can say that not any material is possible. Material is possible. Possible. Which can be 100% rigid. Which can be 100% rigid. Rigid. Okay. And another some parts comes when we discuss further about engineering mathematics, engineering mechanics, engineering, engineering mechanics. First is static, and the second is dynamic. So what can be static? Static means when body is in rest. When body is in rest. What does it mean rest? Means there is no motion in the body. Okay. And what is dynamic? Basically dynamic means when body is in motion. When body is in motion. Basically body is moving from one place to another place. That is called body is in motion. We have further two types of dynamic mechanics, that is kinematics, kinematics and kinetics. So both are sounding similar. Basically here is some different, that is in this part, in this kinematics, we do not we do not consider we do not consider what force. We do not consider force, only motion. Only motion we consider. Okay. And what is kinetics? Basically kinetics we consider force and motion both. So it is dynamic. So after all, I have given you overview of engineering mechanics, that basically we discuss it when someone is studying about someone is in the branch of mechanical engineering. So he discuss about all dynamic and kinematics still we have studied in our 11th class or ITJ preparation, but kinetics is something difficult. Kinetics will comes in use when you are pursuing BTech in mechanical engineering. Okay, so I have given you introduction of mechanics. Basically, it mechanics further two types: mechanics of solid and mechanics of fluids. So solids we studied two types: mechanics of rigid body and mechanics of deformable. What does it mean? Deformable means the shape, shape and dimension and size can be change of body. Basically we always do question on deformable because nothing is possible which can be rigid. Although it is just hypothesis that we assume that it is rigid. For that we can easily solve the question, because when body will be rigid then we do not need to calculate what will be length of that body, and after pressing, after applying some force, what will be length of that. So we do not need to do that. That's why we use this concept rigid. Okay, so I have given you overview. Let's move on to the next chapter. Sorry, next page. This is all about maths. Next page is here. Okay. Yeah. So now we will study about resolving force into rectangular component. Resolving force into rectangular components. Rectangular components. Yeah. So basically, how we resolve the force of rectangular component. As we all know that force is a vector quantity. Force is a vector quantity. Vector quantity. So we can't. Add it directly. So we can't add it directly. We need to follow a proper method. Then after, what is that proper method? After taking components of that. So basically, what is vector? You all know that vector means it has magnitude, and direction. Okay. So when we say that it has magnitude and direction, then we can say it is a vector. Basically, how question will come on it, like resolving power. So suppose we have this x-axis and this y-axis. There is x-axis and there is y-axis. Positive y, positive x, and here will be minus y, minus x. So suppose we have given this angle theta. Suppose this is 5 Newton. What is one more thing, that what is unit of force? Unit of force is Newton. There is in CGS. What will be MKS? It is in dyne. 10 to the power 5 dyne is equal to 1 Newton. Okay, you all know this in your 12th class. So suppose this is we have. So how we will solve it? This is question. So simply what we do, we used to take components. So always in x-axis we will always take cos. In x-axis here will be cos. So this is 5. So 5 cos theta. In y-axis we will take always sine. So here will be 5 sine theta. Okay. There was something how we resolve the vector. I hope you have understood that x means cos. We will always take angle towards x. We will take cos, and then y we will take sine. Okay. So now let's move on to the next topic. I have told you that how to resolve the vectors. And now what should we discuss? Moment of force. Okay, moment of force. So what is moment of force? What is moment? It tends or try to rotate the body. So what is moment of force? When force is acting in body, moment of force when force is acting on body. When force is acting on body, so it So this force have tendency have tendency to rotate the body, to rotate the body. Okay, so it is called movement. Suppose for example we have this body, this is one force and this is another force. So this force will be x-axis and this force will be minus x-axis. Suppose we have this, suppose we have this, and we have two forces. This will be this side, this will be this side. So I will do this, I will be applying force this side. So this body is rotating. So we can say that it tends to rotate or it rotates the body. That is called movement. How we calculate moment? Like summation of effects. So basically component of this, and then if division x-axis, then x same, and then y same, and if we put equal to 0, then after we calculate moment. And suppose now here we are doing second concept, moment of couple. Moment of couple. Moment of couple. So basically, what can we say? Same they face moment of couple. We can also say. So according to this, we can say it has two parallel forces but in opposite side. It is defined as same parallel forces, same parallel forces, but opposite side, opposite side, remember this, opposite side, and with the same magnitude. Parallel forces will be same with the same magnitude. Opposite side or direction, not a different thing. And it is separated by perpendicular distance. So what is moment of couple? Defined as the parallel forces acting on the opposite side or opposite direction, like this. So suppose this is one force, there is another force, and it is separated by perpendicular. This is by perpendicular distance. Okay, so as I have told you that it will tend to rotate. So basically what is moment is equal to force into distance. This is distance and this is force F1 F2, and what will be moment? F into D. Okay, this will be moment. Okay, now let's move on to the second page. So now we will study about Varangian theorem. I think Varangian is the name of scientist or something. We can say physicist. So what is Varangian theorem? Basically what he says, that was all moment of forces moment of forces about a point, about a point, moment of forces about a point. Okay, about a point is equal to the sum of the moment, sum of the moment sum of the moment that component that component component that component of that about to the same point, about to the same point, same point. Okay, so basically moment of forces about a point is equal to the sum of the moment that component of that about to the same point. Okay, definition I am not able to think about this definition. Let me take one example. Suppose we have this and we have this angle, something like this. This is 30 degree. Okay, this is 100 Newton. This distance is 4 meter. So here, how you will calculate the resultant of it? You cannot calculate, right? Like the here, this is not separate. This is aligned with this body. So here we use Varangian theorem. Okay. So how we use Varangian theorem? So simply, as I have told you that what will be component of it, this will be 100 newtons, 100 cos 30, and this will be 100 sine 30. Okay. Hmm. 100 cos 30 and 100 sine 30. Now simply when we will calculate resultant force, then we will multiply by 4 because this all multiply by something like this and this something like this. So 4 will multiply from both equation. So we can write 4 into 100 moment of A is equal to 4 into 100 cos 30 minus 4 into 100 sine 30. So let me use calculator. So we can solve something like moment of A equal to 400 into cos 30 is root 3 by 2 minus 4 into 100 sine 30 is 1 by 2. So this will be 2. So this will be 200. So 200 root 3 minus 200, right? So let me calculate it. 200 into root 3 into root 3 is equal to 36 346 minus 200, right? 200, 146. Moment of A is equal to 146 point something, 410. 410. Okay, so this is something how we calculate moment of forces. Okay, so now we will study about force system. Force system. Basically, there are so many types of forces. Suppose we are giving force in only x direction, or we are giving force in y direction, or just this side and this side, this side and this side. There are so many forces. Like here will be collinear forces, parallel forces, concurrent forces, non-parallel, non-concurrent forces. Okay, so we will study about this. So basically, forces system. Force system, it is a combination of several forces. As I have told you, combination of several forces. Okay, so force system can be further divided. Force system can be further divided in coplanar forces or non-coplanar forces. Non-coplanar forces. This which always happens in 2D. Coplanar forces, or this is in 3D. What is D? D means dimension. What is 2D and 3D? 2D means simple in x, y direction. 3D means x, y, z. X, y and z direction. All directions. Okay. So we do not study about 3D, only 2D. So further, there are some types of 2D. First it comes collinear forces. Collinear forces. Second it comes parallel forces. And third it comes concurrent forces. And fourth it comes non-concurrent or non-parallel. Okay. Yeah. So non-concurrent, non-parallel forces. So these are four types of forces in coplanar forces. Okay. One more thing, that what is concurrent forces? Concurrent forces means all forces passes through through one point only, one point only. Okay, so this is concurrent force. And parallel force, simply you all know that this force and this force, it is called parallel force or this force. Collinear forces, simply like we can easily calculate it. And this is something non-concurrent, non-parallel. So what is this? Like concurrent, I have given you example. Suppose this is here, this is point. So this is passing from this is passing from this point, and this is passing from this point. This is concurrent system. And what about non-concurrent and non-parallel? So suppose we have body something like this. And this is something here, force. This is here, this is here, this is here, this is here. So it is non-parallel, non-concurrent. So this is all about this. Okay, let's move on to the second page. And why are we studying of this? To find resultant. What is resultant? Single force couple which can replace other forces, which can replace other forces of that system Okay, so that is called resultant. Let's move on to the next page. Okay, so basically what I discussed in this class, in this page, simple Varangian theorem and moment force of system, and then this resultant. Now simple, we will studied part wise everything. Collinear forces we will not study because it is very simple to calculate. We study about parallel forces, then concurrent forces, then non-parallel, non-concurrent forces. Okay, so first of all, resultant of parallel forces. Resultant of parallel force. Okay, so resultant of parallel force. Suppose we have this body. We have this body, which point A and which point B. From here to here, it is distance. Suppose 100 meter, 100 mm. Okay, and V. Suppose we draw force in this direction. There is 50 Newton. And second force in this direction, that is 20 Newton. So it is parallel. This is parallel to this, right? So we can say this is parallel forces. Oh, sorry. Okay. So we can say this is parallel to this one. So we can say this is parallel forces. Now we can simply say that both forces are same side. Then we can simply add. So what will be resultant of it? This will be 70 Newton. Okay. It was simple till here. Suppose someone said, what will be resultant here? What will be resultant here? What will be here? Then we calculate it. Okay. So here we will use Varangian theorem. Varangian theorem comes in use when someone said find force in this point and this point. So after taking component, we find that. Suppose we have to find force. This is A, this is B. We have to find resultant here. Okay, the distance is x from here to here. Okay. So Here we have to find moment of A. What will be moment of A? This is x, this is 70 Newton. We have found the resultant. So we are here finding the momentum. So Waringin theorem comes in use when we find moment. Got it? Yeah, so moment of A is equal to this is 70 Newton, this is x, so this is clockwise, so this is anti-clockwise. We take anti-clockwise positive. I take this, you can prefer something else. There is no universal rule that if it is in anti-clockwise then we will take positive, or clockwise we will take negative. There's not any rule, so I prefer this, that's why I take it. So here will be 70x is equal to what was B force was 50 Newton and the distance was 100, right? So 50 into 100. Okay, so this to this, then I can write x is equal to 500 upon 7. It is around 7 7 is 49 and 1 7 1 is 1, then 4 to 8. Okay, so x is equal to this 71.428. so this is positive, so we can say that we assume resultant in the correct direction. That's why we have this positive value. Now resultant of concurrent forces, we have seen the parallel forces. Now resultant of parallel forces, resultant of parallel forces, sorry, not parallel, concurrent forces. What does it mean by concurrent? I have told you that if forces passes through only on one point, that is called concurrent forces. And I have told you that this will be something like this, forces from here, and this we will take it vector. Then this is, suppose this is theta, and this is x direction, this is in y direction, so we take it, suppose this is m, so m cos theta and m sin theta. Okay, we take this, so alpha is equal to tan inverse, suppose this is f1, this is f2, alpha is equal to tan inverse f2 sin theta upon f1 plus f2 cos theta. It is the basic formula to use it. Okay, and should I do question on it? Although resultant forces are concurrent, to find it very easy. So now I should move ahead. Method of projection. Okay, suppose we have this, then we have this, this is f1 and this is f2, suppose this is f3 and this is f4 and this is f2. Okay, so resultant force is basically the summation of fx square plus summation of fy square. So it is the resultant force. Or if we want to calculate alpha means angle, then I can write tan inverse summation of Fy or summation of Fx. Okay, how we will calculate summation of Fy, summation of Fx? By calculating these all angles. I'll do question on it. So how we will calculate summation of Fx? Suppose we have this is angle theta. By the doing component of it, this will be F1 cos theta, this will be F1 sin theta. Okay, by solving the component of it, we will put here and then we will get the value. Let me do one question on it. So we have question. So we have question something like this. Suppose this is y direction, this is x direction. We have given force, there is 20 Newton, angle is 30, and one force is in this direction, it is 30 Newton, and this is 35 Newton, 45 degree, and this is 40 degree. And this is 25 Newton. Okay, so we have to resolve it. We have to resolve component. Resolve component. We have to resolve component. How we will resolve component? Simple. Like this is this. So this is y direction. So here we can write 20 cos 30. This will be 20 sin 30. And same with this. So this will be 30 cos 45. This will be 30 sin 45. And there was 35 Newton. So this is x-axis. So we will write 35 cos 40. We will write 35 sin 40. Okay, so we have resolved all components. Now what we will do to find summation of Fx? Summation of Fx, what we will do, that we will see how many forces is in x direction. So like this is 20 cos 30 is in x direction, so we will take it positive because this is in positive x-axis, and here this is 35 cos 40 is in negative, 30 cos 45 is in negative, so we will write it minus. So basically summation of Fx is equal to 20 cos 30 minus 30 cos 45 minus 35 cos 40, this 35 cos 40. Okay, yeah, so this is summation of Fx. Yeah, so this will be summation of Fx. If we can solve further, then what will be this? 20 cos 30 root 3 by 2, then 20 into root 3 by 2, 10 root 3 minus, let me use calculator, 30 cos 45, 30 cos 45 is 21.5. Although we know the value of cos 45, that is 1 by root 2, so root 2 into root 2, so 215 into root 2, this will be this. Okay, and now minus 30, now 35 cos 40, cos 40, 35 cos 40, that is 26.8. It's 26.8. 26.8. So simply we will add both of this. So 8 5 13, carry 1, then 0.678, 2 to 4, 48.3, 10 root 3 minus 48.3. So 10 root 3 equal to 17.32 minus 48.3, 48.3, it is minus 30.97. So what is summation of fx? It is equal to minus 30.97, right? Yeah, 70. So one more thing, that why is this minus? It shows that most of the components are in negative. So basically minus tells the direction that it is in negative side. Okay, so yeah, it is done. And now we will calculate summation of Fy. So see here how many forces are in positive. We will take, if this is in positive y direction, then we will take positive, and negative y direction, then we will take negative. So see here, this 25 is positive, so we will write 25. Now see this, sine 30 sine 45, so plus 30 sine 45, okay, and this 20 sine 30 plus 20 sine 30, 20 sine 30, okay. And now it comes, this is done, this is done, this is done, this is done. What is remaining? Is there anything which is remaining? Nothing. And again this is in negative, 35 sine 40 minus 35 sine 40. Okay, I think I have written all forces. This was done, this was done, this was done. Yeah, so let's calculate it. Summation of Fy is equal to 25 plus sine 45 is 1 by root 2. So 30 into 1 by root 2, we will rationalize it, and this will be root 2. So 2 15 root 2, this is 15 root 2 plus 20 sine 30 1 by 2, this will be 10 minus 35 cos 40, 35 cos 40, 26.8. So let me calculate it all. So basically 25 plus 10, 35 plus 15 root 2, 35 plus 15 root 2, 35 plus 15 root 2 is 56.2 minus 26.8, 26.8 is 29.41. So summation of, see this, 29.41. So summation of Fy is equal to 29.41. Okay, so we have calculated the summation of x and summation of y. And now what we will do, we can also draw a diagram, that this was suppose diagram, This is x and this is y. Positive is resultant. Okay, so what is x? This is 30. Oh, sorry, not like this. Something to erase it. Is that remember that I told you that what does it mean by negative? It tells the direction. So direction will be this. This is x and this is y. This is minus x, this is y. So this will be component. This is alpha and this is resultant. So what is x? Summation of x, it is 30.97. What is summation of y? It is 29.41. So I have written the formula that what is the formula resultant, that is this summation of fx square, summation of fi square, and what is angle formula is this. So we know resultant formula is equal to square root of summation of fx square plus square root of summation of fi square. Let me calculate it. First of all, put the value. Resultant is equal to summation of fx is this, means 30.97 square. Here do not need to write negative because anything to the power is negative square will be positive. So summation of fi is 29.41 square. Okay, let me calculate it. Firstly, so first of all delete it. So we have 30.97 into 30.97 is equal to 959.14 plus 29.41 into 29.41 is equal to 864.94. Okay, now square root of 959, square root of 959, square root of square root of 959.14 plus square root of 860 plus 864.94 is equal to 895. Sorry, camera is shaking. Okay, $895. Suppose we take it simply this, then 94 is 13, 6, 5, 11, 12, 1, 8, 9, 17, 18. square root of 1823 42. Yeah, so this will be around 42 point something. Resultant is equal to 42 point something. Now we will calculate angle. Angle is equal to summation of fy summation of fx. Okay, so what was fy? Fy was 29.41. Fy was sorry. Fy was 29.41. Fx was, let me check. Fx was, what was fx? Fx was 30.70. Fx was 30.97. One more thing, that here comes tan inverse. Tan inverse. So 29.41 upon 30.7 3.97 is equal to 0.94. Alpha is equal to tan inverse 0.94. Or suppose we want to find it in inverse, then tan inverse 0.94 sorry. So we can write it, or the angle will be, or we can write the angle will be alpha is equal to 74, around 747 around. Okay, now one thing is getting remaining, that is resultant forces of non-parallel or non-concurrent or concurrent. So it is remaining. Basically, I have told you that what is non-parallel, non-concurrent. So we can discuss. Actually, my phone is getting discharged and 1 hour is almost done. So thanks for watching.